Hello, this is Thomas J. Linneman, author of Social Statistics, Managing Data, Conducting Analyses, Presenting Results. This is the SPSS demonstration for Chapter 13 on Logistic Regression. As you learned in Chapter 13, in logistic regression, we have a dichotomous dependent variable. And for this example, we're going to use a variable that asks the respondents, have you done volunteer work in the past year, yes or no? So there's our or variable. Let's look at the distribution of that variable really quickly. The variable is a recoded version called xy do vol, do volunteering. And we see that just under 56% of the respondents say no, they have not volunteered in the past year. 44% say they have volunteered in the past year. We want to explain that variation, so we're going to run a logistic regression to do so. Up till now, in regression, we've always gone to linear regression. We're going to go down a few more, and we're going to go to binary logistic. So analyze regression binary logistic. And in here, it's set up just like the other regression box. So we're going to put our dependent variable there. And we're going to use 4 independent variables. We're going to use the recoded education variable, xy_educ. We're going to use the recoded religious attendance variable, xy_attend. We're going to use the original age variable, which was fine the way it was, so we'll put that in right like that. And then we're going to use the recoded nativity variable, which is xy_born. And then you just click OK, and it gives you a lot of boxes. Only some of which are going to be useful to us. So here we have the total number of cases included in the analysis is 3,508. Scrolling down, lots and lots of stuff that we're not going to use. Here we have the R squared, and as I talk about, you get 2 different versions of the R squared. I opt for the Nagelkirche R squared. And that's 13.6%. We have another box that we don't need. And here's the good stuff. So here are our slopes. Here's our constant. Here are all of our variables reach statistical significance. And as you know, it's kind of hard to interpret these as they are. So I'm going to recommend that if you want to show the effect of a variable, that you create a graph. And for that, as you know, I like to do my graphs in Excel. So we're going to focus on the effect of education. So I'm going to hold religious attendance constant at 2. I'm going to hold age constant at 50. I'm going to hold nativity constant at born in the US. And that allows me to simplify this equation so that I only have the constant and years of education. So I'm going to jump over to Excel now, and I'm going to have a column for education, and I like education to range from a pretty reasonable 8 to 20. Those numbers in here. There we go. Now, as you know in logistic regression, you need to calculate a z-value, and that's what we use the regression equation for. So once I do that math and hold the other variables constant, I end up using as a constant a negative 2.91. And to that, I'm going to add the 0.192 times the years of education. Okay, so that's my z value for someone with 8 years of education. I'm going to take that and copy it all the way down. And now, as you know, in logistic regression, we have that extra step, which is we need to calculate the probability of volunteering. And that's where we use that little equation. Now, in Excel, we use the natural logarithm is symbolized by exp. So we want to multiply that by the z value. We want the natural logarithm of that z value. That's what we want. And we're going to divide that by 1 plus e to the z. So I'm going to put little parentheses there. I'm going to do 1 plus exp, and that number, parentheses, and then I need one more parentheses there. Okay, so just to reiterate, I have e to the z divided by 1 plus e to the z. Hit enter. And that's the probability for someone. So that translates the z value into a probability. Then I'm going to drag, copy, and drag all that down. And now I can draw a graph. So I'm going to grab my probabilities here. I'm going to insert a line graph. And now I don't want the bottom to read 1 through 13. I want it to read 8 through 20. So I'm just going to, I'm not going to format the whole graph, but this is a very useful thing to show you how to do many times. I'm going to select the data, edit, grab 8 to 20, and it changes that. And so we see that someone with 8 years of education has about a 20% chance of saying that they volunteered in the last year. And then that goes up precipitously until you get to someone with 20 years of education who has about a 70% chance, a little over a 70% chance of saying they volunteered. So that is it. It gives you, SPSS gives you a lot of output. You use only part of it. And I think it's a really good idea to take your results and to make them understandable to as many people as possible to create a graph. That is the end of this SPSS demonstration.